Okay, if you're asked to find an Euler path, so what that is a path that passes through each edge of a graph exactly once. This is a very good theorem. So what we're going to look for is we're going to look at each vertices and see how many edges that it has. It says if there are no odd vertices, then there is at least one Euler path, which is also an Euler circuit, which an Euler circuit says that it begins and ends at the same vertex. If there's exactly two odd vertices, then it has at least one Euler path, okay, but it doesn't mean it has to start and stop at the same. And that's what this is saying here. Each Euler path must begin at one of the two odd vertices, and it will end at the other. If a graph contains more than two odd vertices, then it neither has an Euler path or circuit. All right, so let's see, what in the world does that mean? So first of all, this is going back to my graphs. I want to figure out how is this the correct answer. I mean, I'm already showing you that that's the correct answer. Well, things once again I can look at is I can see that P is going to connect to O and Q. So I know it can't be this one because it doesn't even connect to Q, and it's connecting, oh, I'm sorry, and also S, I should say, but it's not connecting to Q. P is connecting to O. Well, doesn't look like that one is connecting to O. P is connecting to O, and that one's not, I guess I picked the correct first step. Okay, so this one isn't either, but let's just look. P is connecting to O. It's then connecting to Q, and it's connecting to S. And then you could check all the others. Like you can see Q is connecting to O, and actually everything else, right? It's connecting to P, R, S, and T. So we know this is the correct answer. Now, so it's asking, the next part of the question is asking you, does an Euler path exist? So what you have to do is you have to actually look at, and let me get rid of that, you have to look at the number, looking at a vertices. Remember that last slide said that if you have exactly two, okay, or first, if there's no odd vertices, then there's definitely an Euler path. And you can start anywhere and you can get through it, where you hit every single vertices. If there's exactly two, then there is at least one Euler path. If there's more than two odd vertices, then neither the path, Euler path, or circuit exists. So what does that mean? Well, if I look at, like, let's look at Q and see from here, there's 1, 2, 3, 4, 5. So there's my first odd one. All right, if I look at O, 1, 2, 3, so I already know that I'm up to at least 2. And if I look at R, 1, 2, 3, so now I have figured out that there are more than two odd vertices, which says there is neither an Euler path or an Euler circuit.